Good morning, students. In the previous lecture, we have learned about the second law of motion and the mathematical formula of the second law of motion. So, today we are going to learn our last law of motion, that is, third law of motion, which is very important. It appears as a simple law, but it teaches the concepts of the actions and reaction forces. So, the law explains whenever one body exerts a force on the another body, the second body exerts an equal and opposite force on the first body. So, we can say that for every action there is an equal and opposite reaction. So, what does this mean? This means that for every force there is a reaction force that is equal in size but opposite in direction. That is to say that whenever an object pushes another object, it gets pushed back in the opposite direction equally hard. So, the third law of motion states that when one object exerts a force on another object, the second object instantaneously exerts a force back on the first. So these two forces are always equal in magnitude but opposite in direction. So now this is the examples to illustrate the Newton's third law of motion. Now let us consider two spring balance connected together as shown in the image and fixed to the another end of spring balance A with a rigid support like a wall. Now pull the free end of the spring balance B. It is observed that both the spring balances show the same reading on their scales. So, this phenomenon observed and prevails that force exerted by the balance A and balance B is equal and opposite in direction to that exerted by the balance A on the B. So, the force exerted by the balance B on A is called as action, while the force exerted by the balance A on the B is called as the reaction. So this is the example of third law of motion. Now let us take us another example. As you have observed many times that if you are sitting in a boat and you try to jump out from the rowing boat, so in that condition what happens? So in that condition when you jump forward, the force on the boat moves it backwards. So from this we can say that two forces are equal in magnitude but opposite in direction. So every action has an equal and opposite reaction. Now let us consider another two objects, that is A and B. Suppose if object A exerts a force on object B, let's say Fa. So in that condition B will also apply the same force in the opposite direction. So according to the third law of motion, Fa is equals to minus Fb, as you can see in the figure. So what does negative sign represent? They represent Fa and Fb both are in the opposite direction. So this is all about the mathematical interpretation of the third law of the motion. Now as you had seen that during recoiling of the gun, the bullet that comes out from the gun has very high acceleration. So, why this has happened? That the bullet acceleration is high, but the gun that is providing a force at backward. why their acceleration is not high as compared to the bullet. So again their explanation is Newton's second law of motion. So according to that, force F is equal to mass into acceleration. If I rearrange this and make acceleration subjects of the formula, then A is equals to F upon M. So from this equation, acceleration is inversely proportional to the mass. It means whose mass is less, so their acceleration is more, and those whose mass is more, then their acceleration is less. So as seen in the image, the mass of the bullet is very less as compared to the mass of the gun. So the less mass in the bullet, in the bullet it has high acceleration. Because of that, they travel a very distance very fast, while the mass of the gun is more. So because of that, if there is a recoiling, there is not in high acceleration. So we can say that A bullet is equals to F upon M bullet. So all these laws are interconnected or linked with each other. So this is all about the third law of the motion. Now we are going to learn our next topic, that is the last topic of our chapter, that is conservation of momentum. So in physics, conservation means no change. That is, if we connect conservation with momentum, then it means momentum does not change or the momentum remains constant over the time. So according to the law of conservation of momentum, when two bodies act upon one another, the total momentum remains constant provided no external forces are active. So this law can also be stated as momentum is never created or not destroyed. So the important point is that in this, the conservation of momentum is only applicable to an isolated system of the object. Now, what is the meaning of isolated system? Basically, it is a system that is not acted upon by an external force. It means this is the system where no unbalanced force is considered. So, in this theory, we are not going to consider any unbalanced force. Now, let us start with the theory. Suppose there are two balls A and B. The ball A has mass ma. The ball has second ball has mass mb. So both the balls are traveling along the straight line at initial velocity, which is ua and ub. So such that ball A collides with ball B. So during collision, ball A exerts force on the ball B. So let us say that Fa. While the ball exerts force on the ball B, we can say as Fp. So now after collision, the two balls moves with a final velocity with Va and Vb. So in order to understand it more clearly, now let us formulate it. So in the case of ball A, the ball A is moving with a initial velocity UA, which has the initial momentum before collision, which is given by ma into UA. While the ball A moves with the final velocity Va after the collision. So in this case, now the final momentum after collision becomes ma into Va. So if we calculate the change in the momentum. So it becomes ma into Va minus ma into Ua. So if we take ma common in this equation, so it will become ma, and in bracket it will become Va minus Ua. So according to the second law of motion, the force is proportional to the rate of change of momentum. So we can say that in the case of ball A, the force exerted was Fa, which is equal to the rate of change of the momentum. As rate of change of momentum we had already calculated in the above equation, that is ma, which is multiplied by the whole bracket and inside the bracket, that is Va minus Ua, and it is divided by T, because we are considering the rate of change of momentum. Now let us move to the case of ball B. It is moving with velocity ub. So the initial moment of this ball before the collision, it will become mb multiplied by ub. Now after the collision, the ball B moves with the final velocity vb. So in this, the final momentum becomes mb into ub. So you have to calculate the change in the momentum. So change in the momentum is equals to mb vb minus mb into ub. And then if we take mb common, so inside the bracket it will be vb minus ub. So we got the change in momentum is equals to mb into vb minus ub. So according to the second law of motion, the force is proportional to the rate of change of momentum. Then the force exerted by the ball is represented by Fb, which will become equal to the change in the momentum, which can see from the above equation. So the change in the momentum, as we have already calculated, is equals to Fb in bracket Vb minus Ub upon 10. So the Fb is equals to Mb upon Vb minus Ub upon T. So now during collision, we said that the ball sticks together. Here comes Newton's third law of the motion. And according to the third law of motion, every action there is an equal and opposite reaction. So in this situation, we applied this particular law. So we can say that for every force there is an equal and opposite force, which is Fa is equals to minus Fb. Now from the equation, we have already calculated the value of Fa and Fb. Now let us substitute this equation. So it will become MAVA minus UA upon T, which is equal to minus MVVB minus UB upon T. So from the both equation, the T will cancel out. And now the bracket is open, and let us consider the left hand side of the equation. It will become ma into va minus ma into ua, and on the right hand side it becomes minus mb into vb plus mb vb into ub. Now on rearranging both sides, we will get mava plus v mb into vb, and on the right hand side we will get ma into ua plus mb into ub. Now consider the left hand side of the equation. MAVA is the final momentum of the ball A, while MBVB is the final momentum of the ball B. So if we add these two values, so it will give us the total momentum after the collision. Similarly, if we move on the right hand side of the equation, so it can solve as ma into ua, which is the initial moment of the ball A, and mbub, which is the initial momentum of ball B. On adding the two terms, it gives us the total momentum before the collision. So we can say that total momentum after collision is equals to the total momentum before collision. So this is the law of conservation of momentum. Thus, from the above equation, we can say so that the total momentum of the system remains unchanged or it becomes conserved provided no other external force acts on the system. So now we are going to solve the problems based on the third law of the motion. So here is the problem. Read as first. From a rifle of mass 4 kg, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. So we have to calculate the initial recoil velocity of the rifle. So there is a rifle out of which a bullet was fired with a velocity of 35 meter per second. And as a result, the rifle has got a recoil which was in the backward direction. And we have to find out what is the velocity of that recoil of the rifle. So, first step is to listing out all the things that question is provided to us. So, the question is given that mass of the rifle is equals to 4 kg and the mass of the bullet is 5 gram. So, I am converting it into kilogram. So, 5 gram is equals to 0.05 kg and the velocity of the bullet is 35 meter per second. So now we need to find out the velocity of the rifle, that is the recoiling of the rifle. So let us take it as V. Now initially the bullet and the rifle both were at rest. So both of their initial velocity are 0 meter per second. Thus they didn't have any momentum. So the final momentum after firing is equal to the mass of the rifle, that is multiplied by the velocity of the rifle plus mass of the bullet multiplied by the velocity of the bullet. So that final momentum after firing is equals to 4 into V plus 0.05 into 35. So after solving this, we get the result, that is 4V plus 1.75. But according to the law of conservation of momentum, we know that initial momentum is always equal to the final momentum. Or in the other words, the momentum is always constant for a system. So if there is no external force acting on it, so the initial momentum before firing is equals to the momentum of the system after firing. So we can easily equate this value. So on doing that, we have from the law of conservation of momentum, initial momentum is equals to the final momentum. So then initial momentum is 0 is equals to 4V plus 1.75. Now the thing we know here is the V, and we can find out easily from this expression what is the velocity of the recoil of the rifle. So here we have to take 4V on the right hand side is equals to minus 1.75. Then we have to take velocity is equal to minus 1.7 upon 4. So by solving this problem, we get the velocity of the rifle, that is minus 0.37 meter per second. So now we found this velocity negative here. So this symbolizes that the velocity of the rifle was in the opposite direction to the velocity of the bullet. And we also know that practically. So that is the reason we got the velocity negative. So this was the solution of this problem. I hope the solution was fully understandable to you. Now evaluation. First is two objects each of mass 1.5 kg are moving in the straight line but in opposite direction. So the velocity of each object is 2.5 meter per second. So before the collision during which they stick together. Then what is the velocity of the combined object after collision? Now the second question, that is an object of mass 100 kg is accelerated uniformly from a velocity of 5 meter per second to 8 meter per second in 6 seconds. So you have to calculate the initial and the final momentum of the object and also find the magnitude of the force exerted on the object. So you have to solve this by yourself. And the last one is the hammer of mass 500 gram moving at 50 meter per second strikes a nail. So the nail stops the hammer in a very short time of 0.01 second. So what is the force of the nail in the hammer? So this is the three questions that you have to solve at your home. And this is the end of our chapter, that is force and laws of the motion. Thank you.